I've been working on this project for about a year now, and it's a circuit that controls the charging and discharging cycles of the supercapacitor. I have my timer that controls this process, and I have its corresponding resistors and capacitors that set the timing of the timer. And I need to give a separate voltage to the timer because it can only get a maximum input of 15 volts. So I have this voltage regulator that regulates the voltage to 12 volts. It's known as a 7812. And this gives a separate voltage to the timer because I'm charging the capacitors with 30 volts, and each one of these capacitors are 6.3 volts at 1 farad, and since I have 3 of them connected in serial, I have 1/3 of a farad at 18.9 volts. This is a small block which actually has an if-else statement, and it also controls the charge cycles and discharge cycles by turning on the corresponding transistors for the charging cycles and turning off the corresponding cycles for the discharging cycles when the timer gives a high voltage. And when the timer gives a low voltage, then this will turn off the transistors that allow electricity to flow from the fans to the capacitors, and turn on the transistors that allow the flow from the capacitors to the battery. And so I'm charging the capacitor and I'm discharging its energy into a battery, so now I'm trickle charging the battery. Hi, this is a prototype that I built and tested for my project. It has 5 Canon DC motors which pull a very high voltage, and 2 of the motors are actually pulling a very high current and pretty low voltage. And all of these motors are connected in serial, which gives me a pretty broad range of a very high voltage and a significant amount of current to drive these capacitors. As capacitors work on voltage and not current, that's why I wanted to pull a very high voltage over current. These are 2 photos of the car with and without the fans. As you can see over here, the fans are mounted right in front of the grille of the car.